since Lab 4 is so different from the kind of programs that we've written so far, there's no graphics and we're using these getters and setters and toString method and such, we thought it would be a good idea to review Lab 4 and show you the output or the results that you should have gotten for Lab 4, and to talk a little bit about these new concepts. So for Lab 4, you were given a starter program that consisted of a class that represented information about a clothing item, and then a main program that called methods, actually declared, instantiated, and used methods from clothing item objects. So if we go to NetBeans here, here is the clothing item class that you were given, and one thing to notice is that at the beginning of the class we have declared properties, two strings, a double, and an integer, okay, with different names. Since there are four properties for the clothing item class, the constructor method for the clothing item class accepts four parameters and stores those parameter values in the appropriate property with an assignment statement. So that's very standard for the constructor method. Next we have a toString method. The purpose of the toString method is to build a text string that includes the properties of the class with descriptive text, so that we can simply print a line that would have all the information about this particular clothing item object. Okay, then, oh, and notice it uses this decimal format thing here so that it prints the price with two decimal places. Even if it's like a whole number, it'll print the two zeros for the cents. Next we have the getters, and the getter methods all have the same structure. Okay, they accept no parameters and they return a data type which matches the property that's being returned. And so the body of the method is simply return whatever. So get type, return type, get quantity, return quantity, etc. For set name, the setters are also, they all have the same format with each other, but it's different than the getters. They are void methods. They are called on a line by themselves, and they accept a parameter which is the value to be stored in the particular property. So set name takes a string parameter, stores that in name. Set price takes a double parameter p and stores that in price, etc. And then we have another method down here called calculate total spent, which can do a calculation with some of these properties. So the total amount spent on the clothing item would be the quantity of that item times the individual price. And that's the answer that's returned. So your task, then let me go here and look at the MU panel. So then in MU panel, we declare several clothing item objects. And in the constructor, we instantiate them with values. This was all given to you. Okay, and then we have this method called work with clothing items. So whenever you call a method with no object to the left of it, that means that that method is going to be defined in the same file. So work with clothing items will be defined below the constructor here for MU panel. And you can see here's work with clothing items, and we have a whole bunch of statements. Now it started off with system out println, and then we changed it to this muta.println so that it prints in a screen window and it looks a little better. Okay, and so you notice we're calling the toString method of different clothing item objects, and then we are also calling, here's calculate total spent. Here we have get price for jeans and set price to the updated price. So it's calling these methods. So you could use this as a pattern for the class that you were to write. Okay. So back here, now your task is to make a new class that represents coffee objects. Okay, and then we also give you the starting data here. So let's take a look at the coffee class. So here's a coffee class for Lab 4. And what you should see is in the directions it says there's supposed to be 3 properties: a string for the size, an integer for the ounces, and a double for the price. With 3 properties, you should have 3 parameters in the constructor and store each of those values in the appropriate property. The property name goes on the left. Here's a toString method, and we told you the format was supposed to be a coffee object with size equal to, and then the property size, and price equal that. Now I think here we need a space in there with a $sign and that. Okay. Oh, and then we also need, this is not correct. I need to go back to the instructions and see. Here's the format we wanted. We wanted, after the size, we wanted a space and then a left parenthesis, then the actual number of ounces. So I'm just going to copy this. And I'm going to go back to the program. Okay, and I will do this. But then instead of 16, we don't want it always to be 16. It should be the ounces property for this class. There we go. So a coffee object with size equal to size, and then parentheses here, and then the number of ounces, and then OZ close paren, and price equal currency dot format price. Okay, cool. So that is the toString method. And then here we have our getters, 3 getters: get size, get ounces, get price. All getters have the same format: public and something that's not void. It's got to be the data type of the thing you are returning. And we have no parameters inside the parentheses. The setters all have the same format. It is void here, and you must accept a parameter because you need a parameter to store that as the new value of that property. And then for this class, there was supposed to be calculate price per ounce. The price per ounce for a particular thing would be the prices, or whatever the price is, divided by the number of ounces. Per means divided by. Okay. Okay, so that is the coffee class. And then back in MU panel, you were supposed to have work with coffee objects. So you print the toString method for each of the cups and the calculating these values here. Print the price per ounce of cup 2 and cup 4. So we have price per ounce. We call calculate price per ounce for the object, and then print that out in currency format for both cup 2 and cup 4. And then reduce the price of cup 1 and cup 5 to 25% of what they were. So we get the price of cup 1 and store that in old price, and then multiply by 0.25 and store that in new price, and then we set the price of cup 1 to new price. And similarly for cup 5. Okay, and then after reducing the prices, we just call the toString again. So if we run this, what you'll see is the MUTA gives you this window where we can have text output, which is nice. And then, so here's the output that came from the clothing items that was given. But then here's the output of the coffee class. So for all the cups, a coffee object with size, whatever it is, and then the number of ounces inside parentheses, and the price. Now, notice it says the price of Grande is $4.30 more than the price of Demi. Is that right? Yes, it is. 7 minus 270 is $4.30. Okay. Venti contains 8 ounces more than tall. Is that true? Yes. 20 is 8 ounces more than 12. And the price per ounce for Venti, okay, 8 divided by 20 would be 40 cents. And the price per ounce for Demi, 270 divided by 3 would be 90 cents. So you can see that it's getting the correct answers. And then you were supposed to reduce the price of cup 1 and cup 5 to 25% of what it was. So cup 1 was $6. 25% of $6 is $1.50. And 25% of $4 is $1. So you can see that those methods worked. So let's go back and sort of take a look at this before we end the video. Okay. Let's check out this statement right here. The price of, okay, cup3.getSize, that retrieves the name of whatever cup3 was. And then we have this calculation, the currency inside the currency format. Notice we have cup3 get price minus cup4 get price. So get price returns doubles, and so we can use that in a calculation. So we do the subtraction, and then we know it's that much more than cup4. And the same thing here with the get ounces. Okay, cup2 get ounces minus cup1 get ounces. Okay, and then the price per ounce, all we do is call calculate price per ounce. We already have that method in our coffee class, which returns the price divided by ounces. So that answer comes back and is stored in the price per ounce variable. And we simply print that for the appropriate cup. Okay, and then once again, let's take a look at this. Reducing the price, we retrieve the current price of cup 1, store that in old price, and then we set new price equal to old price times 0.25. So 1/4 of old price is new price, and then we call the set price method for cup 1 to change the price to this new price. And this is also an illustration of when you have a getter method or a non-void method, the way you call that method is as part of a larger statement. So we take the answer that's being returned and do something with it. In this case, we store it in old price. But a setter method, a void method, is called on a line by itself. So notice cup1.setPrice is not part of a larger statement. It is called just as like a standalone statement. Okay. All right, so hopefully that's a review of Lab 4. Please contact your instructor if you have questions.